Solving quadratic equations by using square roots, part 2. Today we're going to learn how to solve quadratic equations by taking the square root. So first, you have to write the equation with x squared or u squared equals d. So this means that it has to be the variable squared and equals a number in order to take the square root of both sides. So you have two possible solutions, two real solutions or no solution. So no solution, an example of this would be taking the square root of a -3. You can't take a square root of a negative number and get a real solution. First, we're going to refresh our memory about simplifying square roots. So when you take the square root of 25, if you put this in your calculator, or if you just think about it, the square root is just undoing a number that has been multiplied by itself. So the square root of 25 is 5. Because 5 times 5 equals 25. So those are perfect squares. So 25 is considered a perfect square. So if you take the square root of anything that is a perfect square, you get a whole number. So simplifying square roots are simplifying things that are like the square root of 12. 12 is not a perfect square. So when you take the square root of 12, you will get a decimal, but we don't want decimals. We want everything to stay with a square root inside of the solution. So we're going to do something called prime factorization. So prime numbers, 2, 3, 4, 5, 4, not 4, 2, 3, 5, 7. Typically odd numbers, 2 is the only even prime number. So if you multiply 2 times 6, you get 12. And then 2 times 3, you get 6. So this is called a prime factor tree. And these are the numbers at the end of the branches that we look at, the prime numbers that this factor tree created. If you multiply 2 times 2 times 3, you get 12. But what we want to do is know how to simplify this square root of 12. Because a square root is undoing something that has been multiplied by itself, then every two numbers, one number comes outside of the square root. So we have 2 outside of the square root, and the prime number that's left over goes up underneath the square root. So every two prime numbers, one number comes out, and that number left over stays up underneath the square root. Let's do another one. We have square root of 24. So 2, which is the smallest prime number, we're going to start with that. 2 and 12 equals 24. Now we can break down 12, 2 and 6. We can break down 6 into prime numbers, 2 and 3. So these are the prime numbers we're looking at. So remember, every two prime numbers, one number comes outside of the radical. So we have a 2 outside the radical, and then we have a 2 and a 3 left over. So we're going to multiply 2 times 3. So the simplified version of this square root is 2 square root of 6. Now the last one, number 4, is square root of 11. If you cannot take the square root of 11 or draw a prime factor tree, it stays square root of 11. Do not make it a decimal. So square root of 11 equals square root of 11. Okay, so now we're going to get into the lesson. Solve each equations by using square roots. So remember, you have to have x squared isolated or by itself on one side of the equal sign in order to take the square root of both sides. So what this square root does, it eliminates the second power. So it eliminates the 2, the second power, it undoes it. So we have x by itself. And remember, in algebra, what you do on one side, you have to do on the other. So we have x is equal to plus or minus the square root of 49. It has to be the positive or negative of that square root. So x is equal to plus or minus 7. If you put the square root of 49 in your calculator, we know that 7 times 7 is equal to 49. So the square root of 49 is 7. All right, number 2. Remember, we have to isolate the x to the second power. So we're going to get that by itself by using algebraic rules. We're going to add 9 to both sides of the equal sign. So 3x squared is equal to 9. And then we're going to divide both sides by 3. So now we have x squared by itself. So x squared is equal to 3. Now it is in a position to get the square root, to take the square root of both sides. So the square root of x squared, we can cancel out that x, that squared. So x is equal to plus or minus the square root of 3. The positive or the negative of the square root of 3. Number 3, we have z minus 6 to the second power is equal to 25. So it's set up like this. The first thing we have to do, this looks a little different, but we need to get rid of whatever's raised to the second power first. We need to get rid of that exponent by taking the square root. So we're going to take the square root of both sides of the equal sign first. So now we just have z minus 6 remaining equals plus or minus the square root of 25. The next step, we are going to simplify the square root of 25 because 5 times 5 is 25. So we can say z minus 6 is equal to plus or minus 5. All right, so z minus 6, we can actually break this up into two different equations. So z minus 6 is equal to 5, and z minus 6 is equal to a negative 5. So we always have two solutions. So we're going to add 6 to both sides of the equal sign. So z is equal to 11. We're going to add 6 to both sides of the equal sign, and z is equal to 1. All right, for the last one, first we have to isolate our parentheses. So we're going to divide both sides of the equation by 2. So we end up with x minus 4 raised to the second power is equal to 12. Then next we have to get rid of that exponent. So we take the square root of both sides of the equal sign. So now we have x minus 4 is equal to plus or minus the square root of 12. So now, can we simplify 12? Let's think about that. If we did a prime factor tree on 12, we can. I'm sorry, this is a 6. So we have our prime factor tree. So 2 times 2 times 3, every two numbers, 1 comes in front of the radical, and we have our radical simplified, 2 square root of 3. So let's rewrite this. X minus 4 is equal to plus or minus, positive or negative, 2 square root of 3. So next we have to get x by itself because we're trying to find what x equals. So we add 4 to both sides of the equal sign. So now we have x is equal to 4 plus or minus 2 square root of 3. No, you cannot combine those two together, so you leave it like that. So you can look at radicals as like terms. You only can combine them together if it's the same number up underneath the radical. And 4 does not even have a radical, so you cannot combine them together.